Ever catch yourself wondering how kids really get their heads around math? I mean, it's one thing to memorize multiplication tables,
Right.
but really grasping it's a whole other ballgame. So today we're diving into a fascinating link
Okay.
between a kid's ability to focus and their math skills. And stick with us, because this is way more than just an academic thing. It
Mm.
really gets to the heart of how we understand learning.
Yeah, it's like peeking behind the curtain to see what makes a young mathematician tick.
Exactly. And to guide us through this, we've got some seriously cool research to lean on.
Right.
A meta-analysis, actually called Inhibitory Control and Mathematical Ability in Elementary School Children. A pre-registered meta-analysis.
Excuse me.
Right. Just came out in December 2024 in the Educational Psychology Review.
Mm.
And what's really neat about meta-analysis is it's not just looking at one single study.
Oh, I see.
It's taken a whole bunch of them,
Right.
pulling them all together to give us a much clearer picture.
Exactly. And this particular one really dug deep. It crunched the numbers from a ton of individual research projects.
Wow.
So the findings are pretty solid.
That's what we like to hear.
Our mission for you today is to break down what this meta-analysis tells us. Understand if and how these focusing skills really connect to math ability.
Love it. So let's unpack this, starting with inhibitory control.
Okay.
What exactly does that even mean when we're talking about a child learning?
So at its core, think of it as your brain's ability to tune things out. It's suppressing irrelevant information or actions.
Hmm.
So you can zero in on what actually matters, like a mental filter for your brain.
That's a great analogy. Like when you're trying to put together a puzzle, but the TV's blaring in the background.
Oh, yeah.
Inhibitory control is what helps you block out that noise and focus on those shapes and colors.
Exactly.
Now, this study looked at two main types of this control, right?
Yeah,
Response inhibition and interference inhibition.
that's right.
Can we break those down a bit more?
Sure. So response inhibition is about stopping yourself from doing something you've already started or planned to do. Like imagine a game where a kid has to press a button every time they see a green light, but not for a red light.
Got it.
If they hit that button for red, that's response inhibition failing.
So it's like that stop signal in your brain.
Right. It's that mental break.
Makes sense. And what about interference inhibition? How's that different?
Interference inhibition is more about ignoring distractions that are right there mixed in with the info you need.
Okay.
Let's say a kid is trying to solve a math problem, but there are extra numbers on the page that aren't part of the actual calculation. Interference inhibition lets them focus on the right numbers
I see.
and ignore all that clutter.
So one is about stopping an action, and the other is about tuning out distractions around you.
Exactly.
Got it. Now let's shift gears a bit and talk about mathematical ability.
Okay.
How did this study define that? Because it's got to be more than just acing a test, right?
Absolutely. They took a really broad view. They defined it as a child's capacity to learn, use, and remember mathematical information.
So it's the whole package.
Yes, from understanding basic number concepts all the way to tackling complex problems.
So everything from knowing what 5 means as a little kid
Right.
to solving a multi-step word problem down the line.
Precisely.
Yeah.
It's the whole spectrum of math understanding and skill.
Yep.
And if I remember correctly, they even looked at whether specific areas of math were more linked to inhibitory control than others.
They did. They considered different areas like arithmetic, problem solving,
Yes.
just grasping numbers in general. But did they actually find that any particular type of math had a stronger connection?
You know, that's what's interesting. The specific area of math didn't really change the relationship with inhibitory control.
Ah,
The link seemed pretty steady, whether it was basic calculations or those trickier reasoning problems.
so that ability to focus seems pretty important across the board when it comes to math.
It does.
Now, I know that past research on this has been a little mixed.
It had.
Some studies found a link, others didn't. What was the big question this meta-analysis was trying to answer? It sounds like they were trying to settle a bit of a debate.
That's exactly it. They knew the existing evidence was murky.
Yeah.
Some pieces hinting at a connection between focus and math skills,
Right.
and others just not fitting in.
It's like a puzzle with some missing pieces.
Exactly. So
Yeah.
the main goal was to get a clearer answer by looking at everything together. See if, on the whole, there's a reliable link.
And they weren't messing around when it came to the amount of data they analyzed. This was a huge undertaking.
Oh, it was massive. They pulled together results from 241 different findings across 86 separate studies with over 14,000 elementary school children. That's a ton of data.
That's incredible.
Yeah.
So after all that number crunching, what was the main takeaway? What did they find about the relationship between focusing and math skills in these young learners?
The big news. A statistically significant, moderate, positive correlation between inhibitory control and mathematical ability.
Wow.
They calculated an average correlation coefficient, or R value, of 0.19.
Okay, an R of 0.19. Now, for those of us who aren't statisticians, what does that actually mean? How strong of a connection are we talking about here?
Think of it like this. A zero correlation means absolutely no relationship. A correlation of 1 or -1 would be a perfect relationship.
Got it.
So this 0.19, it shows a definite positive trend.
Right.
Kids with better inhibitory control tend to be better at math and vice versa.
Right.
But it's not an ironclad link. It's more like a noticeable tendency.
That makes sense. So it's real, but there's more to the story.
Exactly.
Now, you mentioned earlier they looked at those two types of inhibitory control separately, response and interference. Did they find any differences there?
This is where it gets really interesting. Mathematical ability actually had a stronger connection with interference inhibition. Remember, that's the ability to ignore distractions.
Right.
Compared to response inhibition, stopping yourself.
Interesting.
The correlation with interference inhibition was 0.21.
While response inhibition was lower at 0.14.
So tuning out those distractions seems even more important for math than just stopping an impulsive action.
It does.
Why do you think that might be?
Well, if you think about what kids are doing in math, even really young kids, they're often faced with problems that have a ton of information, some useful, some not.
Right.
Think about those word problems with extra details thrown in, or even just a page full of numbers where they have to pick out the right ones.
Yeah.
Being able to filter out the irrelevant stuff, that interference inhibition, seems super crucial for doing those kinds of problems well.
It's like finding a specific spice in a messy spice rack.
Exactly.
You've got to be able to ignore everything else to get what you need.
That's a great analogy. And while starting yourself from blurting out an answer is helpful,
Sure.
that constant need to sift through information in math might just put a bigger demand on that interference control.
I get it. Now, one of the things I love about a good meta-analysis is it can also tell you what doesn't really matter. Absolutely.
Were there any factors they looked at that didn't change the link between inhibitory control and math ability?
Yeah, and this is really helpful to get the full picture. They examined a whole bunch of things that you'd think might influence this connection, but a lot of them just didn't move the needle.
Oh, wow. Really? Like what kind of things?
Well, like we talked about before, the specific type of math problem didn't really matter. Also, the different ways they measured inhibitory control in those original studies, you know, the kinds of tasks they used, that didn't change the overall correlation much either.
That's interesting. You think different focus tests might lead to different results?
You would, but the general trends stayed the same. What's more, things like the kids' ages in the studies, boys versus girls, their developmental levels, socioeconomic background, even where the studies took place geographically, none of it really changed that basic link between inhibitory control and math ability.
That is quite a list of things that didn't have a big impact. What does that tell us?
It tells us that this connection between these focusing skills and math ability in elementary school kids is pretty solid. It's not just for a certain age group or kids from a certain background.
Right.
It seems to be a more general pattern in how these skills work together during this stage of development.
Really valuable insight. So we've got this moderate positive link with tuning out distractions being a bit more important. And it seems pretty consistent across different kids and settings.
Yeah.
Now, I know the study abstract also mentioned some practical implications of these findings. What kind of new ways of thinking about learning math might this research open up?
Well, the researchers suggest that by focusing on inhibitory control, especially filtering distractions, their findings give us a brand new understanding of what makes up mathematical ability.
So it's about more than just the math itself.
Right. It suggests supporting those underlying cognitive skills might be just as important as teaching specific math concepts.
So maybe if we help kids get better at focusing and ignoring distractions, it could actually boost their math skills too.
That's a question this research definitely raises, and something future studies could look into more deeply.
Fascinating. And I saw that the data for this study is publicly available.
It is.
Which is a great sign of transparency.
Absolutely. They put their data and code up on the Open Science Framework, OSF.
Wonderful.
The link is https://osf.io5a3p.
Perfect. So anyone who wants to really dig in can.
They can.
Which is great. So as we wrap up this deep dive, what would you say is the most important thing for our listeners to take away from all this talk about inhibitory control and math?
I'd say the key message is that there's a real connection between a child's ability to focus and control their impulses, especially that skill of ignoring distractions,
Uh-huh.
and how well they do in math in those elementary school years.
And why should our listeners care about this?
Because it gives us a deeper understanding of what mental skills really matter for learning math.
Right.
It goes beyond just thinking about some innate math talent
I see.
and shows how important these basic cognitive abilities are.
So here's a final thought to ponder. We've talked about correlation,
Yeah.
but what about cause and effect?
Yeah.
How do these focusing skills and math ability actually affect each other? Could training a child's focus actually lead to them becoming better at math?
Mm-hmm.
Or could learning math actually help strengthen those focusing skills?
That's a great question. It's a bit of a chicken and egg situation.
It is.
Definitely something fascinating for future research to untangle.
Absolutely. And for those of you who are interested in learning more,
Yeah.
we encourage you to check out that data on OSF
Yes.
or explore some of the individual studies mentioned in the meta-analysis.
Great idea.
Thanks for joining us on this deep dive.
Thanks for having me.